Right, so last thing we're going to look at this week is basically a connection between doing arithmetic with complex numbers, but doing it in polar. Okay, yesterday we multiplied and divided, especially with division. Okay, that's a pain. You got to find the conjugate, then you got to multiply the top and bottom by the conjugate, which means foiling it out, changing all I squareds to -1, combine like terms. Okay, that's a lot of work. We can make all that work go away. Okay, if we decide we're going to do everything in polar, we're going to be able to do it in our head, okay, without any foiling. Okay, so the polar form of a complex number gives you a quick way to multiply and divide, rather than worrying about all the foiling and all the I squared stuff. All right. Now, this is only quicker if your numbers are in polar form. If your numbers are already in rectangular, maybe it's quicker to just do it in rectangular, rather than change it to polar and do it this way. Right? But if they give you numbers that are in polar to start, it's going to be extremely fast. All right. So just say we have two complex numbers in polar. Okay? When we do a problem, R1, this will be a number, and θ1 will be a number. Okay? These just represent any radius and any angle. All right, so my first complex number is R1 cosine θ1 plus I sine θ1. Now, if I'm going to multiply, I need a second number. So we'll call that Z2. Okay, and Z2 has a different radius and a different angle. They don't have to be the same. Okay, these are two different complex numbers. And if we want to multiply these two numbers together, okay, all we have to do is two things. We're going to take R1 times R2. Okay, start with that. And the second thing we're going to do is take θ1 plus θ2. I'm going to add these angles together. And that's it. That's all we have to do to multiply two numbers together. Take the two radii that they give you, multiply them. Take the two angles that they give you, add them. You're done. Okay, this whole thing is going to take the place of everything we had to do before. No foiling, no I squareds, no combining like terms, no conjugates. Just take your two radii, multiply them. Take your two angles, add them. You're done. That's the whole problem. Okay, so here's two complex numbers, okay, in polar. I want to multiply them together. Okay, so this is where we would start doing all our distributive property, okay, if they were in rectangular. Okay, we're not going to have to do any of that this time. All right, so first thing I do, look at my two radii. Okay, and what do I do with my two radii? Multiply them together. Okay, so what's my radius going to be here? 15. Okay, so that's the radius. Okay, you don't need to use Pythagorean theorem. You're not going to use inverse tangent. Again, that all goes away. So 15. And then we've got cosine. What's my angle going to be? 120. 120. You're done. That's the whole problem. Okay. Any question on that? Yeah? Mm-hmm. Right, so the advantage here, if it's in polar, you don't have to know any of those other formulas. Okay, the inverse tangent, the r squared equals x squared plus y squared, foiling, none of that. Okay, you can pretty much do it in your head. Okay, very, very easy. Right, let's try, make it a little bigger. All right, let's try this one. Okay, z is 1/2 cosine 15 plus I sine 15, and w is cosine -30 plus I sine -30. Okay, does everybody have example 1? Okay. All right, what's my radius going to be here? Yeah. R1 times R2, 1/2 times 10. Okay. And what about my angle? Negative 15. Yep, we'll talk about that. Any question on how we got the 5 or the negative 15? We just multiplied those, we added those. Now, when you get a negative angle, there's there's a few different ways we can write it. No matter what we do, this is always 5. Okay? What's another way I could write this? Getting rid of this negative angle without making the angle bigger. Yep?
5 cosine 15 minus I sine.
Yeah, that's equivalent. Okay, so all we did was get rid of the negative on cosine, put the negative on sine in front. Okay, what's another way we could do it? Besides, let's say we didn't know this rule about the negatives canceling or moving in front. What could you do to negative 15? You could add 360. Okay, and if you take negative 15 plus 360, you get 345. Okay, so that's a different way to do it. Cosine 345, I sine 345. Okay, the point, you're not going to have to write the same problem 3 different ways on the test. Okay, my point here is if you get a multiple choice question, and let's say you get that as the answer, but I have that listed, you have to understand these are the same. Okay? Or maybe I'll list it the second way. Okay? You just have to understand how to make your answer match what I have. But these are really the only ways you'd write it. Okay? These would be the only options.
If it's not a multiple choice, can we just leave it as the first one?
Yeah, if it's not a multiple choice, as long as the directions don't say what to do, you can leave it any way you want. If the directions specifically say don't leave negative angles in your answer, then you have 2 ways you could fix it. And either way would be correct. Okay, so any question on multiplying complex numbers in polar? Right, so if we can multiply, division is pretty much just as easy. Okay, I'm going to use the same setup I did last time. 2 complex numbers. Each number is going to have its own radius and its own angle. Okay, just based on how we did it last time, what do you think we're going to do with our radii this time? If we're going to find the quotient, we're going to we're going to take R1 divided by R2. And think about what we did last time with the angles. What do you think I'm going to do this time? I'm going to subtract. Okay, the only thing that might be tricky about this is it's so similar to the other formula, you might mix it up. Okay, but don't mix it up. Put it on your reference sheet. When you're going to divide, you take R1 and R2 and divide them. You take theta 1 and theta 2 and subtract them. And does the order you subtract 2 things in matter? Yes. 2 minus 4 and 4 minus 2 aren't the same thing. Okay? So make sure you keep theta 1 minus theta 2. Okay, and the same thing can happen here. If you get a negative angle, there's a couple ways we can deal with it. If it doesn't ask us to deal with it, we don't have to. We could leave it as a negative angle. All right. Now, when we do this, this is where we would have it set up. We'd have to find the conjugate of what's in the bottom. We'd multiply top and bottom by the conjugate. We could use the trick in the bottom to do that quick. But then the top, you'd have to FOIL, combine like terms. All the I squareds got to go to negative 1s. It'd take forever. Okay, you should be able to look at this and find the radius and the angle in probably five seconds. Okay, and you don't need any decimals. Just leave things as fractions. Right, so what's my radius going to be here?
3/5.
3/5. That's it. Don't change it. Cosine, what's my angle?
45.
75. Take away 30. 45. Done. That's the whole problem. Okay. Any questions on that one?
What happens if, say, z was 3 cosine 75 minus I sine 75? Can you still do it?
I'll never give you a problem where it doesn't have plus and plus in the original.
Okay.
Yeah. You could, but we won't get into that. Okay, the original problems will always have plus and plus, just like that. Okay, so our last one for division. 10 cosine 20 plus I sine 20. 1/2 cosine 100 plus I sine 100. All right, so my radius. Okay. What's my radius going to be here?
20.
20. How'd you get 20? Because I bet some people aren't thinking 20.
Because when you have a fraction, you do the reverse with the denominator.
Yeah, so it's 10 divided by a half. So you're asking how many times does 0.5 go into 10? Not 10 times a half, 10 divided by half. Okay, that's 20. All right. But another way to think of it, think about how many half dollars make up $10. 20. Okay, so your radius is 20. And what about my angle? Negative 80. Okay, and this time, let's just rewrite it one way. We could add 360. Let's just do it so we get rid of the negatives. Okay, what would it be if I rewrite it, just getting rid of or moving the negatives?
20 cosine 80 minus I sine 80.
Yep, the negative on the cosine, that just goes away. Negative on the sine goes in front. Okay. Any question on division? Okay, so now we got a quick way to multiply and divide, assuming they give us numbers in polar. Again, if your answers aren't in polar to start, it might be more work to change them to polar. You know, depends. Right, last thing. Right, this is called Moivres Theorem. And what this does is it gives us a trick, a very, very easy trick to raise a complex number to a power. Okay, so let me show you without this how much of a pain it is to raise something to a power. Okay, and I'm not even going to do that high of a power. I'm just going to raise it something to the third power. Okay. So let me show you what that looks like, and then imagine I raise something to the 300th power. Okay, it would be 300 times is worse. Okay. So let me just take, and I'm not even going to use big numbers. Okay, I'm going to use 1 plus 2i, and I'm going to cube it. Okay. If I wanted to do this out in rectangular, it means to do this. 1 plus 2i times 1 plus 2i. Okay, we did that yesterday, but now we have one more. Okay, and the way you do it, you just go one step at a time. 1 times 1. 1 times 2. Okay, I have another 1 times 2. So that gives me 2i plus 2i. And then 2i times 2i. 2 times 2 is 4. I times I is I squared. What number is that really? That's negative 4. So we've got this. And what's 1 take away 4? Negative 3. So Any question on just multiplying that times that? Okay, now we got to do it again, okay, because we're cubing it. Right, so we FOIL it out again. Negative 3 times 1. Negative 3 times 2 is negative 6. 1 times 4 is positive 4. And we get 4 times 2 is 8. What's I times I? I squared. Okay, I combine my like terms. I have negative 6 plus 4 is negative 2i. And what's 8i squared?
Negative 8.
Negative 8. So my final answer, what's negative 3 take away 8?
Negative 11.
Negative 11 minus 2i. Okay, so it's not that bad. It's not like it was the world's hardest problem, but it does start to get annoying. And then imagine I did it to the 39th power, or even 395th power. Now I need to put 1 plus i times 1 plus 2i 395 times and do it out. Okay, even if you could, you're going to make a mistake somewhere. Okay, so there's got to be a better way than what we just did. And there is. Okay, it's going to be just as easy as multiplying and dividing. Right. So the trick to raise a complex number to a power, okay, first of all, assumes you're in polar. Okay, and you do two things. You take your radius and you raise it to the power. You take your angle and you multiply it by the power. All right, there's not going to be a second complex number here. Okay, you're just raising something to a power. So all you need is one thing. One thing, raise it to a power. Okay, so raise your radius to the power, multiply your angle by the power. And that's going to take the place of doing everything we just did. Okay, not that great of a shortcut if you only had to cube something. Okay, we just did it together. You could do it. But if you had to raise something to like the 20th power, you can do this. I could do the 20th power or the 2 millionth power just as fast with this trick. Doesn't make a difference. Right, so here's my complex number. And they want me to raise it to the 8th power. To do this in rectangular, pretty bad. You'd have to multiply out 8 sets of parentheses, one at a time. Okay, even for me, that's going to take me at least 10 minutes just to do something like that. And there's so many FOILs I'd have to do, I'm probably going to make a mistake. All right, so let's start with our radius. Okay. What would be my calculation for my new radius?
3 to the 8th.
3 to the 8th? Which, if it starts to get really big, we just leave it. We don't even do that out. Okay, we'll see how big that is in a second. Cosine. How do I get my new angle?
Power.
Yep, I use the power, use the angle, and what do I do with the two of them?
Multiply.
Multiply them. What's 8 times 20? 160. And that's it. Yeah, let's just leave it like that. So take your radius, raise it to the power, take your angle, multiply it by the power. And it takes the place of all that foiling you would have had to do 8 times. So any question on de Moivres theorem? Okay, so now you got a quick way to multiply, divide, and raise a number to a power as long as your numbers are in what form? Polar. As long as they're in polar. All right, so homework is same page as last night. It's page 333, 33, 35, and 37, and then 41 and 42. Okay, in 41 and 42, I think they ask you to convert something to rectangular. Just leave your answers in polar. Okay? Don't do what they're asking you to do in 41 and 42. Just leave it in polar. Okay? And don't forget, test tomorrow. Okay, you can use a reference sheet on the test. And we'll review this right before we take the test.